Hello everyone. In today's session, let's talk about Docker Swarm tool. As part of it, let us try to see what are the limitations we have in standalone Docker engine. Let us say as an administrator, you are trying to manage multiple Docker host missions. You might have installed Docker engine on a virtual machine or on a physical server or in the cloud environment. It doesn't matter for us. Let us see what are the limitations we have. For example, you might be running some application on one node, let's say app 1, and you might be running another application on another node. Now these two applications want to talk to each other. For that you have to do some additional configuration like external load balancer, or we have to configure some networking side in order to establish a communication. That is one of the challenge what we have. Second thing is, now as an administrator, before launching the application, I have to see what are the resources are utilized on that node and what are the space that is left. And based on my application requirement, I have to decide whether I can launch the application here or not. I have to take a manual decision on that. And if that node is not suitable, I have to go to another node. You have to SSH, verify the resource utilization, what is your application requirement, and then you have to decide whether to launch or not. And this is a manual process. It is not an automated one. That is the second challenge what we have. Third challenge is nothing but if you want to deploy your application as a high availability, I need to deploy that application on multiple nodes. If I use a single node, what will happen? If that node goes down due to hardware failure, due to software failure, or due to network failure, or due to storage, or due to power outage, anything could happen, right? Now the application is not available to access. In those conditions, how we can provide a solution? We need to have multiple nodes, and my application has to be distributed on these multiple nodes, or else if the node is not available, I have to replace that node, or my application has to get shifted to another node without any downtime. Then what you are supposed to do? I need to run that application with multiple copies on a different nodes. Doing this particular task is not that easy without using any additional configurations or settings. That's the reason why to overcome these particular challenges, now we are going to use Docker Swarm tool to form the cluster. Now the first question which everybody will have is, what is the meaning of cluster? In a generic way, cluster is all about managing multiple nodes together is called as cluster. Now what is meant by Docker Swarm cluster? Managing multiple Docker host missions together is called as Docker Swarm cluster. In that cluster, you have two types of nodes. Before the two types of nodes, you need to ensure that what are the nodes you want to use in the cluster, you have to deploy Docker engine on all the missions. It could be a virtual machine or a physical machine. First, you have to install Docker engine. After that, you have to configure Docker Swarm cluster. Means you have to enable Swarm mode. Now, in that Swarm mode, we have two types of roles. Either it has to be a manager node or it could be a worker node. And one more point here is your manager node can act like a worker as well. What does it mean? I can deploy my applications over here and I can deploy the applications over here as well. It is possible to do. And if you want to disable this particular node to act like a worker, we can do that. That points we'll discuss one by one. But in the cluster, the major important topic is we have two types of nodes. One is master and slave, or we can call it as manager or worker, or we can also call it as control plane, compute plane. Though the technical terms are different, the concept will be the same in the cluster point of view. Now, how the data is getting distributed among the manager nodes to maintain high availability, which means if I go to any manager node, my request, I have to see the same content. Now, how this particular data is getting distributed? By using internal distributed state store with the raft consensus. This is one of the underlying technology what your Docker Swarm is using in order to establish this particular data distribution. To enable this functionalities, Docker Swarm is using Swarm Kit. That is one of the product which is used as an open source in order to enable these features. So on top of Docker engine, you are enabling this particular functionalities to create a Swarm cluster. That's the easiest way to understand this concept. Now, let us understand what are the key concepts we have in Docker Swarm. First one, as I told you, it works on a master and slave basis. We can also call it as master and worker or manager and worker. Now on that particular nodes, we have to install Docker engine. Without doing that, we can't create a Swarm cluster. That is the first point we need to remember. Second point, manage multiple Docker engines nodes together is called as cluster. Now what is meant by Docker Swarm cluster? Managing multiple Docker engine missions together is called as Docker Swarm cluster. Same point I have written here. And then manage a node, what it does, it performs orchestration and then it performs cluster management functionalities to maintain the desired state of the swarm. For example, I want to launch my application. Is it running or not? Those things and orchestration as well. In the sense, I will say, I want this particular things to be created. I will write in a declarative form. And that particular things will be managed by your orchestration functionality inside the manager node. These are the things what it takes care in the backend as a manager node. And what about the manager node? It will receive the request and then it will try to create a task. Imagine in Docker engine it is called as container. In a Docker Swarm it is called as task. In order to create that particular task, we have to create a service. I will explain you that particular hierarchical model. But we need to understand that if you want to create a task, the request will go from the manager and that will be received by your worker and then it will try to create a task. And that information will be given back to the manager node. This is the job of the worker node in the cluster. Now, manager node by default acts as a worker as well, where it can schedule the task. If you don't want that particular manager to be acting as a worker node, we can disable it. How to do that? It is called as drain mode. We can set that particular manager node into drain mode. What does it mean? So that if you try to launch applications, those applications will get launched only on the worker node, not on the manager node which you have set it to drain mode. Next point, worker node has an agent that will be running on each and every worker node. What it does exactly, it will ensure that the task has been assigned to that particular node. It will generate that report and then it will verify whether the task is running as expected or not. Now this information will be given to the manager node whenever it has requested. And that request will come to the agent that is running on the worker node. Next point. Services are defined as a task to execute on the manager or worker node. Now, let us try to understand this concept. In a Docker engine, if you want to launch an application, we have to create a container from the image that we already know. And if you try to compare with Docker Compose, there we call it as service. For that, we have to write a compose YAML file, which is a declarative approach. In that compose YAML file, you will write all the specifications, how many containers you want to launch, what the name you want to assign, which image you want to use, what volume you want to specify, what network you want to define. You will specify all these things and what command you want to execute after the container has been launched. You will declare all these things and then you will apply the compose file that is called as orchestration. Even in the service of a Docker Swarm tool, we will try to create a service in a declarative approach to create a task. The task will be running on the worker nodes. We will be creating a service will be creating a task, and task will launch a containers. Inside the task, you might have one container or more than one container. That's what we need to understand. And that is a hierarchical structure. Now, in order to create the service, we have totally two models. One is replication mode and one is global mode. What is meant by replication mode? If I try to say create a service with replica is equal to 3, what does it mean? Your Docker Swarm manager will understand that we have to create totally 3 tasks. Let us say you have 5 worker nodes. The task right now might be created on a single worker node, or it might be created on 3 different worker nodes. The decision will be made by the manager, which it will have internally a scheduler. Though you have 5 nodes or 10 nodes, it doesn't mean that your task will get launched on each and every node. If you want that functionality, then we have to go for global mode. What does it mean? Number of nodes is equal to number of tasks. As simple as that. If you have a requirement, I want to launch my task on each and every node, then you have to go for global. No, I don't have any requirement like that. I want to run only 3 tasks. Where it is running, I'm not worried about it. Then you have to go for replication. Next point. The key feature of networking in this particular cluster is nothing but overlay network. By using overlay network, we are able to achieve this particular communication between the nodes, where you are trying to distribute the task among the nodes, and they are able to communicate with each other because of the overlay network. And then not only that, Docker Swarm has internal DNS where it will allow you to establish a communication between the services running within the node or across the nodes inside the cluster. And one more point which is so important. By default, all the communication is secured in the Docker Swarm cluster. Why? Because it is using two concepts called MTLS authentication and encryption. For any communication that happens within the node or across the nodes inside the cluster, it will use the component to component communication by using MTLS authentication. By default, it is secure. And moreover, it uses encryptions. Encryption in the sense, what are the data that you try to transfer within the node or across the nodes inside the cluster will get encrypted by using certain algorithm. Forget about the algorithm, what it is using in the backend. The communication is more secure because in order to decrypt the data, we need to know the key. That key will be known only by your Docker Swarm tool. That's the reason why it is more secure data transfer. Now from this, what you need to understand, Docker Swarm is an advanced features of your Docker engine. But if you need that particular functionality, we have to enable Docker Swarm mode. Now let us try to understand the workflow of when I try to create a service, what Docker Swarm cluster will do in the backend. Let us understand theoretically. For example, I want to create a service. As I told you before as well, in a Docker Compose point of view, in a Docker Swarm cluster, it is called a service. Now we are trying to create a service. Now the request from the CLI, it will go to the Docker Swarm Manager. And in the Swarm Manager, we have Raft. In the Raft, we have a component called API that will receive the information. The command what you have executed will be received by API. After that, it will go to the orchestrator. What this orchestrator will do, let us say I want to create a task. It will see continuously or it will watch continuously whether the service has been created or not. So it is a continuous loop that will get triggered in the backend until the task has been created for the service. And then we have allocator. After that, it will try to assign the IP address to the task that has been scheduled on the node. And then we have dispatcher. What it does, it assigns a task to the node. That will be done by your scheduler. On which node it is feasible, that particular decision will be made by your scheduler. On that particular node, your task will get scheduled. With this, the job is done by the manager. Now the request will go to the worker node. Let us say it has decided that the task has to be created on this particular worker node. The request will go to the worker, and on the worker, agent will receive the information, and then it will try to create a containers in the backend with the help of Docker engine. Once the containers have been created together as part of the task, then the information will be sent back to your manager, and manager will give the response with the help of API. This is the workflow in order to deploy an application as a form of service stack in the Docker Swarm cluster. Now, As a final conclusion part, let us understand few points, the features of Docker Swarm. The first one is cluster management integrates with Docker engine. What does it mean? You don't need to install any additional package here. This Docker Swarm functionality is part of the Docker engine. The only thing is you have to enable it. It is pretty easy, right, to create a Docker Swarm cluster. That's the advantage what we have. Next point, decentralized design. What does it mean? You have a manager node and you have a worker node. At any point of time under maintenance, I can convert my worker node into manager, or I can convert manager node into worker, or I can remove the node from the cluster, or I can add a node to the cluster as well. This can be done on the running cluster. For that, we no need to shut down it. That is called as decentralized design. So we have manager node and we have worker nodes. And then declarative service model. Inside the Docker Swarm, it uses orchestration. If you know about Docker Compose is an orchestration tool to manage the resources on the Docker engine. So similar to that, Docker Swarm by default will use a declarative approach in order to create a service. That is an option what we have. And then scaling. Here, for example, what are the services we have created? And you will define how many replicas you want to launch. After a few days, I feel that the number of replicas what we have is not sufficient. You don't need to delete a service and create a new one. On an existing service, we can scale in the replicas or we can scale out the replicas. Whenever I have a requirement, I will increase the number of replicas. Whenever I don't have a requirement, I will decrease the replicas according to the usage of my application. That can be done on a running service. That is also one of the features what we have in Docker Swarm cluster. Next point, desired state reconciliation. What does it mean? Always your Docker Swarm will ensure that your desired state is equivalent to the actual state. If something is mismatched, it will try to replace that particular object to always match your desired and actual state. Then followed by multi-host network. As we discussed, because we have formed our cluster and the applications are distributed on different nodes, now they have to communicate with each other, though they are running on different nodes. And that can be achieved by using internal functionality called overlay network, which is called as multi-host networking. Next point is service discovery. So your Docker Swarm cluster will use internal DNS to establish a communication between the services by using their names. For that, we don't need to configure any additional things in the cluster. They can talk to each other by using the names. And this will become easy for us for an applications to configure with the name instead of IP address. Because IP addresses are not static and they are dynamic. Always I cannot say that I will have the same IP address allocated to my task. Instead of that, I can go with the service names. That's the advantage what we have. Next point, load balancing. I would say Docker Swarm by default doesn't have a load balancing, but if you try to expose the application over publishing the port number with the Docker host machine in the Swarm cluster, we can use an external load balancer to distribute the traffic between the applications running on different nodes. It is possible to do, but it is not an internal functionality. And then we have secure by default, MTLS for authentication, and then we have encryption for data transfer. Finally, we have rolling updates. At any point of time, if I want to apply the changes to the existing service, today we have an image, some X version. After that, we found some bugs and we fixed it on the code level. Now we built a new image. Now with that image, I want to upgrade my application. For that, you don't need to delete the service. On an existing service, we can modify the changes and we can reapply it. That is called as rollout. For example, in the new version as well, we found some bugs. Now I want to roll back the changes. We can do it. These are the major features what we have in Docker Swarm to deploy your application on the cluster. I hope these theoretical points will help you a lot to understand the concept. Thank you.